Okay, we thank Dr. Kashi for his masterful presentation. And now allow me to introduce Mr. Ghasemi from Capco Company, a dedicated expert in chemical admixtures. With a focus on innovation and quality, Capco produces cutting-edge admixtures under his guidance. Mr. Ghasemi's expertise ensures the excellence of Capco's products, making significant contributions to the industry. So please join me in welcoming Mr. Ghasemi. I'm sorry that I mispronounced. He's actually Doctor, so please put your hands together for Dr. Ghasemi.
Hello, everybody. Uh, I should say that good noon. Thank you for all for coming here for our presentation, and I hope my presentation meets your approval. As you see in my presentation topic is effect of polycarboxylate superplasticizer on the rheological behavior of different cement paste. This presentation is a part of the project, a common project between the Capco company and Institute for Color Science and Technology. I should say that is a small part of it. It's a big project between us this project want to estimate and study about the made superplasticizer based on carboxylate on the behavior and the prediction of the behaviors for the usage in the concretes. Okay, on behalf of my co-workers, honorably I present you. We speak about the first subject, introduction, experiment, result, and discussion, and conclusion. In the preparation of the cement paste and concrete, we know that water have an important role. And the main problem, what is that we cannot use extra water for preparation of the concrete because it's limited to the low mechanical properties and segregation and bleeding and instability of the concrete. Then we have this limitation. This solvation, what is the solvation? Using the plasticizer is the very good measure for solving this problem. And here we want to know that how they work. Before, we should say that the superplasticizer lead to increasing workability and increasing the strength of the concrete. Okay, one of the most famous superplasticizer which is used in the concrete preparation is the polycarboxylate ether, which is simplified to PCE. How does they work? The PCEs are the organic compounds that have relatively large molecules with relatively large chains. And from one side, they have a negative charge. This negative charge leads to the stacking or adhering to the cement particles and leading to their separation with each other by steric repulsions. And then the agglomeration that occurred in the cement paste is brick, and the encapsulated water released from inside of the agglomerates. This phenomenon leads to extra water in the concrete that will help us to reduce the content of it, and the reduction is about 30 to 40%. That is valuable for the production and the final properties of the concrete. Um, different factors are studied nowadays, and the researchers focus on different aspects, such as density of carboxylate group, the functional group content, the molecular weight of the side chains, side chain polymer and polymerization degree. The final product of the carboxylate, when is used in the concrete or cement paste, affect the hydration temperature, heat flow, and hydration degree and hydration heat in the concrete that are important. As experimental, simply we had 5 stages. First is related to selection, cement selection. The cement was selected from local factories, PC, and then PC selection. The PCs was made of the Capco company products, and then characterization and paste preparation and the rheological measurement. Our work was in the 2 sections. The first section, we have aimed to study the rheological behavior comprising the shear rate, shear stress, and thixotropy of the cement paste. 4 cement was situated and studied with the 3 type of PCE, and in the in section 2, 1 cement with code of CM14 it was studied with the 4 PCE with aim of study about yield stress, water to cement ratio, and the rheological model. Okay. For studying the rheological behavior, we use the rheometer from Anton Park Company with code of 302, and the accessory used for cement paste was two type of plate and plate and cup for height density and for the paste state. Sometimes the water to concrete ratio is low, and we need to use plate and plate instead of cup. In fact, we studied about for the 13 cement samples, which was from different products of local cement factories in Iran. But between them, according to the different factors such as chemical analysis, Blaine, and zeta potential, and mean particle size, we situated code 1, 5, 6, 12, and 14. As you see in this figure, the zeta potential, which reveals about the electrical charge of the particles, the different magnitude of the zeta potential can be obtained, which was tested by zeta potential apparatus. The variation is from -6 minus to about 8, positive 8. As we know, for the stable systems, colloids, the magnitude of zeta potential should be higher than 35, or minus 35 to plus 35. Then, according to this result in the cements, we can't have stability just according to the zeta potential, and need to steric repulsion too. The microstructure of the cement samples were studied. For example, cement 2, 5, and 12 can be seen here, that the particle morphology are similar relative to each other, and there are small to large particles, and they are similarly to each other. Here we can see the mean particle size of the cement samples for different cement samples. The Gary color are related to the situated cement space. The mean size is from the range of 14 to 21 micron. Okay, the result of viscosity with shear rate shows us the shear thinning behavior for all the cement samples. This is a common behavior for all samples that have been studied and published before, and our samples behavior is similar to them. The shear thinning it shows us the interactions, initial interactions of the particles, such as the absorption forces act between the particles. And according to the SEM figure, you saw that the particles have a small size relatively, and the corners of them are this place that the charge density of the electrical charge density are high, and it leads to the absorption between them, and the interaction relatively is high, especially for low shear rates. If we magnify this section, we see that there is a difference between the cements for viscosity. This is a bare cements and no added the superplasticizer yet. And from other aspects, we can see that the most reduction is under the shear rate of 1 per second. That means that the interaction between the cement particles in the paste state are relatively weak. And here we can see the behavior shear stress with shear rate. The Bingham behavior can be seen for a small shear rates in left figure from 1 to about 10 per second. It is relatively Bingham behavior. And for study the thixotropy, we use the hysteresis of the go and back for the viscosity shear rate, and the hysteresis form reveals the magnitude of the thixotropy. And as you can see, the cement 6 have higher hysteresis, which shows the higher thixotropic behavior related to other cements. Okay. Here we can see sorry, this is the incorrect. The viscosity shear rate. When the PCs was added, the first group of PCs was added. As you can see, after addition the polycarboxylate, the viscosity diminished gradually, and the behavior led to the Newtonian behavior. Especially here, we can see after addition the polycarboxylate 602 and 102, we have the Newtonian behavior instead of shear thinning behavior. Then it reveals us that the interaction between the initial interaction, electrostatic interaction, have disappeared by addition of the polycarboxylate. Then the polycarbonate has attracted on the surface of the cement particle. And similarly for cement 6, it seems the similar behavior, but the cement 901 reveals the shear thinning behavior, but with lower viscosities. And for cement 12, the addition is, shows the similar behavior. Then the behavior of the PCE 902 is different from two other PCs. And about in the next section, about the effect of the solid volume fraction, we studied for the cement 14, the viscosity shear rate with relatively go and back curves, which shows the thixotropy. Relatively, the large thixotropy can be seen even after the increasing the water to cement. And increasing the water to cement ratio lead to the lower viscosity for us. And here the effect of water to cement on the shear stress of cement 40 can be seen. The shear stress with shear rate shows the Bingham behavior. And yes, this is the repeated. Sorry. Yes. The yield stress after addition the new group of carboxylate for cement 14 is lead to increase in the soluble fraction range and decreasing the yield stress, which
3 minutes left, please.
okay, I'm finishing. And the viscosity versus soluble fraction, the yield stress can be seen that the fitted curves reveals us the meaningful. And the relative shear stress, here can be seen that the magnitude of the yield stress, which is in the which can be, this not unfortunately don't work. I show you, then I pass from. The magnitude of the relative yield stress diminished largely with the increasing of the carboxylates. And the compatibility with the present models with Chova model, the good fitness with can be seen. And similarly for Zhu model, we can see the good compatibilities for some paste and some additives. And similarly for Rike model and the UDEL model was studied for achieving the way that we can to predict the behavior of the cement paste for different amounts of the water to cement ratio. And okay, I go to the final page. The yield stress with viscosity showed us the linear relation, and this is one of the valuable results that we obtained, which helped us to the prediction of the behavior of the cement paste. And the effect of Blaine on the yield stress showed that the yield stress shows the relatively linear relation with Blaine. And okay, in conclusion, I can say that all cement paste reveal shear thinning behavior, and the PC shows significant reduction in viscosity and yield stress. PCs enhance the solid loading fraction and workability of cement paste. The rheological behavior of cement paste is compatible with the reference rheological model. A linear relation is seen between viscosity and yield stress for all cement paste. And finally, a linear relation is seen between viscosity and Blaine for all cement paste. Here, I want to thank from the Institute of Color Science and Technology for technical and laboratory assistance, and big thanks to Capco company for funding the project, and especially big thanks from Mr. Ayubi for helping us in this project, and thank you so much.
Thank you. Thank you for your nice presentation. Only one question. Audience? Okay, thank you very much. Yes.
The type of the cement, the cements you have used,
Yes.
which type of cement you have used? Type one?
The type of cement was used from the different companies that produced. For example, the Tehran, Sufyan.
No, all of them were type 1 or 2 or, I mean, 5?
Yes.
All types of cement?
No, no. They were similar to common using cement, for example, Portland cement.
325, something like this, yeah?
Sorry?
Compressive range of cement was the same or?
The cement, in which aspect do you
No,
ask?
the cement you have used, 14
Yes.
type of.
Yes, the type of them was yes, similar. Yes,
Similar.
similar to
Thank
each
you
other.
so much.
Thank you. Thank you so much.